Hi everyone, myself Gokula Varshini and I'm working as an assistant professor in the Department of Food Technology in SNS College of Technology. So today let us see about the topic thermal processing equipments in food industries. So here the topics covered are heat transfer mechanism, conduction, convection and radiation. So, the heat transfer in the food industry equipments is the fundamental in the food processing industry, impacting the safety, quality and efficiency of the food products. So, understanding the heat transfer mechanism is vital for optimizing process like pasteurization, sterilization, cooking and freezing. So, this presentation examines the three primary heat transfer modes. So, first of all it is conduction, convection and radiations. So, we will now explore how each mode functions, their importance in various equipments and practical examples of their application in food industry machineries. So by depending the knowledge of these heat transfer modes, professionals can enhance the process control, improve product quality and boost the energy efficiency in food production environments. So first of all, we shall understand about the conduction. So, conduction is the process of heat transfer through the direct contact between the materials. So, heat energy moves from the regions of the higher temperature to the regions of the lower temperature, enabling the heat transfer of the thermal energy through solid or between the solid in contact. So, this mechanism is governed by the Fourier law, which relates the heat transfer rate to the temperature gradient and the thermal conductivity of the materials. So, the thermal conductivity varies significantly among different food materials and packaging materials, influencing how quickly the heat transfer is transferred during the processing. So factors such as moisture content, density and composition affect the conduction areas. So understanding these properties is crucial to design the equipment and process that ensures even and efficient heating or cooling, which directly impacts the food safety, texture and flavor retention. So first of all, what is definition? We shall see about the definition of the conduction. So heat transfer directly through the contact where molecules collide and transfer energy. So this is the definition of the conduction. So we shall see about the example. So heating a metal pot on a stove where heat flows from the burner to the pot and then to the food inside. So let us see about the dynamics of the convection. So convection involves heat transfer via the fluid movement, which can be liquid or a gas. This process is critical in many food processing applications where temperature, uniformly and efficient heat distribution are essential to ensure the product safety and quality. So there are two primary types of convections, that is natural convection and forced convection. So natural convection is driven by the density difference caused by the temperature gradient, and forced convection is an external force such as a fan or pump enhance the heat transfer rate. Here, Newton's law of cooling describes the relationship between the temperature difference and the rate of the transfer, where the heat transfer coefficient plays a vital role in quantifying convective heat transfer efficiency. So common examples of convection in the food industry includes boiling, steaming, air frying and cooling of the packaged foods. So natural convection, fluid motion generated naturally due to the temperature induced density variation within the fluids. This type occurs without any external mechanical aid in the typical in process like rising of hot air during baking of the convection current in a boiling water. Next is the forced convection. So in here the heat transfer enhanced by the use of the external device such as fan, agitators or pump that force fluid movement. So this type accelerates heat energy and is commonly employed in air fryers, forced air ovens and cooling tunnels, leading to the faster and more uniform temperature control. Next is the radiation heat transfer. Here, radiation transfer heats through the electromagnetic waves without requiring a medium, allowing heat to move through a vacuum or air. The Stephen-Boltzmann law mathematically defines the power of the radiant from the black body in terms of its temperature, highlighting the importance of temperature to the fourth power in radiant heat transfer. So, emissivity, which measures how effectively a surface emits thermal radiation, plays a key role in determining the amount of heat transferred. Surface properties such as color, texture and material composition, along with temperature difference between surface, significantly affect radiation efficiency. efficiency. So common food industry application including boiling, infrared heating and microwave ovens, each utilizing radiation to cook or heat food quickly and uniformly while preserving its quality. So first, so on looking into the definition, so heat transfer via electromagnetic waves where energy is emitted and absorbed without direct contact between surface or a conducting medium. So here the Stephen Boltzmann law states that the total energy radiated per unit surface area of a black body is proportional to the fourth power of its absolute temperature, forming the basics of the qualifying radiative heat transfer. So let us see about the other things in our next conversation. Thank you. If you have any doubts, you can ping me.